Welcome to the Let's Talk Data podcast series presented by SAP.
Hello, and welcome to our Let's Talk Data podcast series. We are in series 3, and throughout this series, we're talking about the power of combining enterprise AI with intelligent information management in order to drive data-driven innovation. My name is Ginger, and I'm your host for this series. In this episode, we're going to talk about some use cases and key capabilities that we need to support those use cases. I'm joined here by two of our leads for SAP Data Intelligence. We've got Mark Hartz here. Mark, thanks for joining us today. Where are you today, Mark?
I'm in Germany. The sun is shining, and it's getting late on my side here.
Oh, that's right. The sun is shining, and Mark, you're always having to work late, and Kevin's always having to work early. So Mark is our product owner, so he's involved in everything about the development of the product, what's going to come with SAP Data Intelligence. And then we're also joined way far away from him, Kevin Poskett. So Kevin, where are you today?
Hey, I'm in Vancouver, up in Canada today, and it is starting to turn into fall. So in Vancouver, that means the sun is not shining, and it's probably going to rain for the next 10 days straight.
Oh, all right, Mark, you've got the better location, even though Vancouver is totally beautiful. So we appreciate both of y'all taking the time to be here. So Kevin is our solution owner, so he's our holistic owner of everything that goes on with the product, including how we deliver that product to you. So these are the best two people, Mark and Kevin, that we can have here today to discuss the major capabilities and how customers are using SAP Data Intelligence and what are some things that we've built to help meet the customer's needs. So we're going to talk a little bit about our favorite use cases and the challenges that those had and how they were solved. So as you guys talk about your favorite use case, I have to throw out mine first because I totally love it. And it's the one I was just on a call the other day explaining to some people about what it is. And this use case, everyone can always relate to it because everyone has a dishwasher. Well, maybe not everyone has a dishwasher. That's not true, but lots of people have dishwashers. And one of my favorite use cases is about a company who makes dishwashers. And they wanted to know both how is the dishwasher performing, what's it doing from an energy perspective, how are the cycles doing, how much water is it using, what's the temperature, to also the user behavior on the dishwasher. So my dishwasher has like 15 buttons and I use 2 or 3 of them and that's it. And what this customer was doing, they were taking everything and putting this stuff into data lakes and trying to analyze all this information. But they kind of got stuck because they weren't able to do it until they were able to use SAP Data Intelligence. And then they were able to combine this information, put some analysis on it, and really see how customers are using the dishwasher and also how they're performing so they can make both a better product and one that meets the customer needs better and they don't waste time on features that customers don't use. I love that scenario. Everyone really starts to understand what data intelligence is with that. But I know each of you have your own scenario, so I'd like to talk with both of you about what's your favorite use case scenario, what challenges have you seen with the customer, and how we're solving it, and what are some of the key capabilities. So, Mark, since it's getting late for you over there in Vancouver, we'll start with you, then we'll go over to Kevin.
So speaking of thinking of my, let's say, favorite customer use case, I mean, there are a few popping in my head. I mean, what I really found impressive is a lot of the challenges and a lot of the gaps customer have to overcome, especially if it comes to where they want to bring together data they have in enterprise systems, or maybe then together with some pictures or unstructured data. And what I remember, which was also a pretty cool case we built, was also with a car dealer. Where they basically wanted to help their salespeople by getting a better estimate how much money they could make with let's say, a resale car. So what they come up with was a solution where they could also take, a picture of a car, and then we recognized, okay, what type is it, and with a few parameters attached, they were able to predict in the end also what they could get back as a value on the free market. And when you think about what you need to bring together, is actually quite a lot, and that is not easy. You need your sales data based on your history, which obviously and hopefully sits somewhere in a SAP system. Then you have a few open sources like reselling marketplaces where you can search for, let's say, comparable models. And then you have the whole algorithm and the whole logic, bringing that together and also predicting how that will evolve. And I think, and that was, of course, more like an innovation case also from them, how they could help their sellers to do better deals and better, let's say, offers to their customers. But if you think that through, you could easily transition that to so many different use cases, which is for me quite fascinating. And I will later talk also a little bit about what the technical means. I mean, the technical things you have to do and overcome, which is actually not that trivial. But I don't sure. Maybe first to Kevin for his use case.
Yeah, so thanks, Mark. And I've got two use cases. One is something that we did that I think is really interesting, and the other is something that came up in a conversation that I just think is funny. So I'll start with the kind of the stupid use case, because no one would do this other than for fun. But I have a friend who's an engineer that I have been friends with since before I owned a dishwasher, Ginger. And he put something on my Facebook page about what is the optimal search pattern if you're looking at Where's Waldo. So it was a correlation of all the places Waldo's been found in books, and then someone actually ran an algorithm to determine the optimal search pattern. And so I thought, what we could do with data intelligence is take it one step further. We could actually take images of Waldo and train a deep learning model to automatically identify Waldo directly inside of a picture from the book. And it turns out that someone's already gone and done this. So just because I thought it was silly, I went and looked it up, and someone has built and scripted the TensorFlow model, has the training data set and everything. So one use case that we will never do, but I thought was funny, is you could automatically find Waldo. Now, a much more meaningful use case would be for organizations that have heavy asset management requirements. So anything with large machinery, and in particular, like in a manufacturing floor, where a single hour of downtime can cost, hundreds of thousands, if not millions of dollars. So what you're trying to do is trying to figure out, one, are we going to have issues in the quality of the finished product? Because those become scrap and it costs us a lot of money? Or is it potentially possible that we might actually have a breakdown on the manufacturing line? And if that's going to happen, how do we prevent that from occurring before the breakdown causes an issue with production? And we have a customer that was kind of doing this. So one of the things that's very common when you're talking about applying AI or machine learning is it's often feasible to address a use case once in an experimental environment. So what they were doing is they were taking pressure sensor readings off of molding presses, and they were also taking infrared images to detect heat patterns on the plant floor itself. And they were taking that pressure sensor data, they were taking that infrared image, and then they were also taking some information out of their ERP system, or their SAP ERP system, around the material masters, the production line, what goods were likely to come through. And they wanted to bring all of this together. So first, they needed to do a feature extraction on those infrared images. So an infrared image kind of looks like, a hippie's flashback, right? It's sort of tie-dyed, it's got green and yellow and red. What you ultimately need to do is break that down into underlying individual components. And so red is generally, that's a heat signature. So you need to know where those heat signatures are, and you have to break that all down. Combine that with pressure data. Generally, when you have pressure, you have heat. And if you have too much heat, that often means that a part can fail, or it could mean that the pressure is too high, and that could cause a defect in the line. So bringing that together and then putting it into a machine learning algorithm in order to output a probability of whether there's going to be quality issues. They were able to do this, but what they ultimately wanted to do was put this into some kind of nice mobile app, so that people on the manufacturing floor could actually identify, here are potential issues in the line, let's go sort them out. The challenge, and this is very common, is even if you've managed to solve the problem once, how do you solve it in a repeatable fashion? So as the line is moving along and things are being produced, all of that data is being streamed and moved in real time. The inference pipeline is there. You're actually getting the probabilistic score. It's feeding into the app. And it's really important in a use case like this sort of predictive maintenance or predictive quality use case that you have it live, because finding out, 3 days later that you knew there was going to be a break doesn't do you any good. You kind of have to know in advance. And so where they used our solution was they were actually able to orchestrate all of these complex flows of data, from image data to sensor data to structured data to unstructured data, involving things coming off of operational facilities, things coming out of their enterprise data center and their SAP ERP system, things coming off of cameras and being routed into a cloud-based data lake. And they could bring that all together, apply these feature extractions and algorithms all in a single solution, and ultimately deliver that data directly to this smart quality app. And now all of a sudden you actually have something that's production ready, meaning it's running consistently. As things are coming through the line, you're getting that data, you're able to address problems before they happen, as opposed to being able to technically solve the sort of data science question of how could I predict when there's going to be a break. That's difficult and that's important. But if you can't put that into a production environment where you're actively making these predictions as the process is going on, and actually putting that directly into the hands of end users who can make decisions before they become critical, then it becomes just an interesting experiment. So what I really like is we took a problem that they had I guess theoretically solved and made it so that it was a production ready solution that was actually delivering value to the business.
That's a good scenario, and with that, I think that's a good place to kind of double click and talk a little bit further about what are the things we had to do both for that to happen, and also Mark for your favorite use case as well. Mark, do you want to start with some of these, or Kevin, if we just go a little bit further on what are some of the capabilities that we had to do and how we're solving the problems?
I'm happy to get it started, and then maybe Kevin, of course, can take it from there. I do see that there are a lot of, let's say, similarities in nearly all of the customer projects and cases we are seeing. And it's not so important exactly what the, let's say, the use case is overall, because technically it's quite often the same pattern. So quite often we first have to think about where can we get the relevant information, and that is usually a set of, let's say, distributed sources. Sometimes there are data lakes included with unstructured data. Sometimes it's just a business system like an ERP system. Sometimes it's just a database. And the first, let's say, challenge and first thing in nearly all of the projects is exactly, let's say, bring these sources together, overcome the gaps, find the similarity in the data, which is quite often the biggest challenge. So to think about what are the same standards, what is the format, how can you do a mapping, for example, that is mostly time consuming. So people spend a lot of time on those activities to integrate and to process the right data at the right place before they can actually do something smart. The part of doing something smart and implementing the fancy part of it, so meaning the AI or the machine learning or applying or training a model, that is then, of course, for the brilliant data science community. But effort-wise, they have to invest a lot before they can actually apply that. So so if I would really name the biggest challenge I see with the customers nowadays is, first of all, that we have these gaps, that we have this distributed sources, and then on the other side, that in a lot of organizations, the knowledge of let's say those tasks and the responsibilities of those tasks are splitted, right? You have your more traditional focused integration IT kind of audience, and then you have a data science, machine learning oriented community. And it's not really a spoiler alert when I tell you usually it's not the same profile of people. So usually those people are different. But to be really successful, I do believe, and to achieve such scenarios, what Kevin and I laid out before, I really think those people need to collaborate. Because in most of the cases I see it's hard for them to collaborate because on the one hand side there is security concerns, there are all of these challenges I mentioned before, which is really, really, really hard for them to find exactly this common view and this common, let's say, way how they can implement that in an efficient way, because there is a lot of fragmentation how they solve it nowadays, and there is a lot of different tooling and methods out there. But what they really need and what would be, let's say, the best for most of those customers would be an end-to-end oriented way, an end-to-end oriented process to really tackle all of these challenges in a way that is consistent and has a certain life cycle attached. And of course, it's not a surprise that this is exactly what we intended to solve also with data intelligence.
So I would agree there and say that, you know, in a number of these use cases, the challenge is somewhat a technology challenge and somewhat a collaboration challenge and somewhat a business process challenge, or rather an evolving business process challenge, in that a lot of organizations that have decided to invest in machine learning or data science have done so in such a way to create these independent teams that are working on really, really interesting use cases, but they're really focused on solving one part of the puzzle. And it's a really important part, which is, if I give you all the data, can you derive some meaningful insight from this data? That's great. The analogy that I like to use here, because I love to cook, is when you have these data science teams, it's almost like, if I give you all of these ingredients, can you make me this amazing meal, right? And your data science teams are like these Michelin star chefs that are creating these incredible, results. That's fantastic. But then the next question is, how do I serve this to 100,000 people? I need to understand what you did with those ingredients. I need a recipe that I can follow, and it needs to be repeatable. I also need to understand what happened to it, and I need to have control over where the ingredients came from, what's being done to them. I need to make sure that, if certain people have food allergies, that I have transparency in this line through the ingredients to the prep, to the creation of the meal, to the delivery, that I know that I'm meeting the needs of my user. The same kind of thing exists when we start talking about, what I'll call scalable enterprise artificial intelligence. We have teams that can do truly amazing things with the data once they have it. But one of the figures that gets tossed around is upwards of 80% of a data science team's time is actually just spent trying to find the data that they need, and then trying to get that data into such a format that they can go and build the models themselves. The development of the model and the really interesting, super technical piece where we have different algorithms and frameworks and we build a model and we think it's a model of good fit, that's where a lot of people think the time is spent. But the reality is, a lot of the time is actually spent just finding the data, sourcing it, making sure I can trust it. Or once I've now got this model, how do I turn that model from this amazing, one-off, completely bespoke, fantastic thing to something that I can repeat over and over and over again at great scale? Because just because I've solved the problem once doesn't mean I can go and solve the problem 10,000 times a day over and over and over again. And that handoff from these data science teams back to IT organizations is often another area where a lot of time is spent. Anywhere between 60 and 85% of models that are shown to have value in a what I'll call an experimental environment don't often make it into production, because the data science teams go back to IT, and IT says, well, we gave you the data and then you did something to it. I now need to be able to replicate everything you did to the data in order for this thing to work. And I don't necessarily know what it is you did, because you've scripted it in a language that I don't understand, or I'm not quite sure where this data even came from. I can't trace it back. So being able to go from how do I give data science teams the agility and freedom to go and find the data that they need from distributed sources, as Mark is talking about, right? So data could come from third-party data providers. It can come from your on-premise data system. It can come from sensors. It can come from logs. It can come from just about anywhere. And how do I make it so I can find that with ease, give the data science teams what they need to go and do the actual work of understanding the data, understanding the business problem, and building the model? And how do I do that in a collaborative way so that when the data science teams turn around and say, put this into production, and I can say, well, I know where the data comes from, I know what you did to it, I made it easy for you to find it, and now because you've done it on sort of the same solution, I actually know everything that's happened, and I know how to put this into production and completely repeat what you've done, and then be able to trace back what has happened and say, if the model's not performing the way that we expected, let's go back and look at how what we've done in production is different than what you did in the experimental environment, and try and figure out how we troubleshoot and diagnose and repair this. So it's not any one individual technology so much as having everyone working together on the same solution, being able to speak each other's language, being able to have the tools that they want and that they're comfortable with in order to do their job, and actually working together as a team and being able to scale out the capabilities of all of the people on that team and play to their strengths, as opposed to just hoping that one team with one very rare and very expensive set of skills can just take care of everything. I mean, I always like to say that the evolution of the data scientist is to go from being the all-star who's doing everything to trying to be more of the coach of the team, and making sure that you're using the capabilities of all the people in your organization, and then, yes, providing your expertise on top of that to break through the technical challenges as they come up on more of the pure play data science and model development side.
But Kevin, let me also place a bet here, because I think that if companies truly want to be successful, they have to overcome that burden and that gap between those different communities. And what I see when I'm currently in customer workshops is quite often that they are already, something like we used to have in the past, like a few years ago. A lot of customers build like business intelligence or BI competence center kind of setups. And I do see that this is repeating right now. I do see that, there are now virtual groups being formed where the data scientists have an active role in it and are embedded in the team and are, they have a fraction of it. And I do think the time has to be over where those people are sitting in a lab environment in their, nerdy cellar kind of thing. And then, that's now maybe oversimplifying, but and we just dump the data there, and then they do something very, very smart, and everybody is happy. I do think to be successful, there need to be new setups, and that's not only, and of course, the tooling as well. But I think the issue and the solution as well is basically to tackle both of them, to have the right tooling, and of course we have something beautiful there, just to remind it again, but also to help those people working together and speaking the same language, and not making it a us versus them, because that is still what I see in a lot of companies, and those are the ones who do something in machine learning or AI, but will not be successful on the long term, I believe.
No, I'd agree completely. And it's interesting when you bring up the idea of the BI competency centers, because my background really started in BI, and a lot of the same things are in fact happening, right? So if we think about where BI came from, we had all of this data that was being stored in on-premise relational database systems underneath applications, and you had business users who simply wanted some insights, generally, backwards-looking insights to that data. What happened? Who are my customers? What's the average order value? And in order to get that, they had to go and work with DBAs who were scripting jobs to get the data out, and then usually giving it to something like a flat file, and probably at that time something like like a Lotus Notes workbook. And an entire industry and category came up around how do we make it more efficient to get this data out. and get this data in the hands of the users who are making decisions. And similarly, you had the DBAs with all of the technical knowledge and know-how and skills to just manually script and extract things. But the second we started making it easier for DBAs to create repeatable processes, then that caused an explosion that became known as business intelligence. And then that evolved and said, rather than just making it easier for these highly technical people to just create the reports that people want, how do we create a framework that the business user can potentially go in and get the report themselves? And the way it really evolved is we had a lot of self-service tools, we had BI competency centers, and we have visualization tools. And we continue to see an evolution towards the cloud, and SAP Analytics Cloud is a good example of that. But a very similar evolution is starting to happen within the realm of, okay, we've got even more data than ever before. And rather than just having a couple of on-premise systems, on-premise relational database management systems where we just need to extract that data, load it somewhere, and build a reporting solution, we now have structured data, unstructured data, semi-structured data, image data, audio data, sensor data. So it's exploded. And in order to keep up with that, a lot of the tools that were created to solve one specific problem. So here's my tool for dealing with structured data. Here's my tool for dealing with how do I store all these streams of data. Here's my tool for managing my data lake. But being able to have, here's a comprehensive single set of tools to manage all of this data and the process by which I extract meaningful value from this data, i.e. utilizing data science in a collaborative fashion. That's really what we're trying to accomplish, and it's the same end goal, which is how do we get the end users, the business users who need critical information to make decisions, how do we get that to them in a timely fashion, in a way that they can understand, in a way that they can accept and trust, and do it repeatably. And that's really, I think, the foundation of where we're going with data intelligence. And it absolutely comes down to this idea that we've proven the value of data science and machine learning. I don't think anyone would dispute that there's significant value there. But now how do we go from these little, what we call skunkwork projects, where we've solved a $10 million or $100 million problem with some incredibly smart people? How do we solve, instead of one $10 million problem, how do we repeatably solve 10 $1 million problems or $100,000 problems, and do that in a scalable way where everyone's working together? And I think when companies are able to unlock that level of scale and collaboration in that model, the potential upside there is astronomical. And I think there's some significant advantages to being one of the first movers that's actually able to embrace this new model rather than trying to keep everything in a separated ivory tower environment.
So Mark, whenever we're really talking about these capabilities that we need to bring this collaboration, and when you guys were originally designing the product, what are some key things that were critical for this, from the data wrangling and the metadata management and the management like Kevin was talking about, to actually operationalize and get things to production? What are some key things that we're providing, and maybe how is it different than other things that SAP has done in the past that's kind of what I think to be kind of really interesting and evolutionary? What do you think, Mark?
Technology-wise, and that's maybe, so I'm more the technical. I do have more the technical background, so that is for me, of course, then maybe the interesting piece. But technology-wise, we really tried to come up with a solution who is scaling, who's running in the cloud, who's running hybrid, which is running on-premise as well, by choosing the latest and greatest container technology which is out there. So that's, of course, from a, let's say, deployment perspective, which is a real innovation, because it was also the first solution by SAP of such a kind, which makes us, of course, proud, and of course give us also the flexibility to be deployed and run basically everywhere. But from a capability perspective, I think what really was super important also for me in the beginning, when we defined the scope and the use case of the product, was really this end-to-end perspective. We really wanted to combine basically the capabilities which are needed to fulfill all of this task which Kevin and I said before. And of course, we cannot be a tool which can do everything, and that's not our goal, right? We just have some boundary conditions, of course. But what we tried is really to bring the most important capabilities together in one platform where you have everything you need from connectivity, no matter to what, not limited to SAP solutions, not limited to systems, but also to, for example, messaging technologies, to data lakes, to cloud stores, to whatever. Then brought together a real rich set of, let's say, pipelining technology, pipelining and orchestration. On the one hand side, moving the data, but on the other also, let's say, triggering the processes which are needed and pushing it down to the best environment to do the job and execute and do the processing. And then on the other side, not forgetting that if there is this someone overseeing this landscape and integrating and processing data, you also need to have an understanding about the quality and the metadata and the structures, right? So we added a data catalog in the solution. So that is, of course, then the second capability now, beside pipelining, cataloging. And then we realized in all of the projects we had in the very early POCs, we realized that most customers are addressing machine learning use cases with it. And we said, okay, then we do believe we need to implement that much more smoother. And what we came up with was then, let's say, the next pillar was an embedded way how you can create and train and also deploy machine learning models by, for example, using then an integrated Jupyter notebook, by embedding predefined machine learning services from object detection to text-to-speech, for example. So we brought all of this together because we believe customers need such a platform, and we do believe those capabilities are belonging together. And we did a lot of analysis and a lot of interviews, and we also learned how customers are doing and implementing that today. And even, for example, in-house, we at SAP, we of course have also such use cases. And we saw one use case, for example, where we also brought together enterprise data, unstructured or semi-structured data. We did some machine learning and tried to bring and loop the results back in an analytical solution. And we used 15 different solutions for that. So we realized, that there must be a business case. There must be a way to do this more efficient. And I'm not saying that we turn them down to one tool, but there is a significant chance to limit the number of participating tools, to have one platform which is leading this process and bringing the capabilities together.
And if we're having this solution that does what you guys have talked about, brings together the data architects, the data scientists, Kevin talked about, it's one thing to do a POC, it's another thing to get it to production with pipelining and cataloging and Jupyter notebooks and everything that y'all talked about. If everyone's like on this collaborative tool where they can all work together and get everything they need and get it deployed and manage it, what does that mean for governance and security, and what are some key capabilities that you found important? I'd like to hear this from both of your perspectives. If we're going to bring everyone together, how are we going to make sure everything's safe?
So, there's a number of different things that we have to think about, but particularly when we start talking about data science in a scalable way, governance and transparency are critical, and they're critical in any data topic, right? So the concepts of transparency as well as privacy are evolving and becoming such an incredibly important topic. So a lot of things that are out there are very black box models. So any number of solutions that will claim to automatically score leads or give you this answer, but how or why was that answer given is often not transparent to you as an organization. And if we think of a number of the use cases that come from customers, if you had a model up and running that told you that this machine part is going to break, so you take your production down line and you replace the part, That's good if it works, but it's causing you a lot of extra expense and downtime if it is a false positive. And the only way that you're going to be able to identify if you can trust the system and if it's a false positive is whether or not you have the level of transparency into why you're getting the answer you're getting out of that model and what data went into that model and what transformations were applied to the data before it got fed into that model. And then if something changes in the data, the model can all of a sudden stop performing, right? So one of the things that's very different compared to, say, a BI solution is you can't just design it once, deploy it, and walk away. You actually have to constantly monitor and make sure that those models continue to give you good results because the signal in the data could change. And if you don't have the ability to some degree to automate that life cycle management, that testing and that retraining, all of a sudden you have humans involved in trying to make sure models are being performant. And that takes away their time to do other things. And again, these are not particularly highly available or low cost resources. So in terms of being able to do it at scale and do it in a way that's trustworthy, a layer of governance is important to understand where the data is coming from. Is it being properly anonymized? If I had some privacy requirement, can I trace where this data is being used if I needed to eliminate or delete it, and what impact that would have potentially on models or reports or wherever I'm feeding this data? And then being able to have the transparency in the design, the deployment, and the management of the models to understand why they're producing the results they're producing, and being able to troubleshoot them if that's the case. And then the third one, and this is really where the human element becomes really important, is how do we make sure that as we are applying basically advanced mathematics and statistics, that we're not making poor decisions because the math is correct, but the math is actually not detecting some kind of human bias, right? So there's this concept of encoding bias. If I take a look at correlations, there's a real strong desire to say this correlation means there's a causal relationship. So if I were to analyze, say different salaries, there most likely in many situations would be a disparity based on gender. Now, most people would say that's an indicator that there's some kind of potential for bias based on gender and salary. And that's a very big and important topic of conversation in general. If we just leapt to the conclusion and said, well, the math says that based on gender, these people make more or make less, and therefore there's a causal relationship, and you put a model into production, you could be making decisions and taking sort of our own biases and directly embedding them into an automated process through a machine learning model. So to summarize, there's three critical areas. The first is, do I know where the data comes from and that I'm protecting privacy as necessary, and I know what's been done to that data so I know I can trust it and prove where it came from? The second is, when I create these models, are they open enough that I can understand why they're giving me the results that they're giving so I can try and diagnose them if something goes wrong? And third, do I have people involved in the process who are very aware of potential biases that the models might be showing us strong correlations, but that doesn't mean that it's a causal relationship, and really applying sort of their level of very humanistic knowledge to make sure that the models you create are accurate in the sense of not just mathematically accurate, but accurate in terms of the results you want to drive, and keeping, in mind the fact that oftentimes math will give you a true answer, but it's not it doesn't have the ability to account for what I'll call, potential human or society-based issues. And those three things are critical to make sure that we get this right, especially if we're going to scale and automate at the level that I think that the world is going. Making one bad decision is obviously a problem. Automating the bias and making 100,000 bad decisions and then lacking the transparency to understand why it's happening, that's a real problem, and it's something that we really need to make sure that we avoid. And that's built into when we delivered this solution. How do we make sure we have the metadata management, the data governance, the lineage, the transparency, the debriefability of models? All of those are tools to make sure not only can I successfully solve one scenario, but how do I solve multiple scenarios get them at scale, automate them, and make sure that we can trust the data, trust the model, and trust the performance of those models.
Mark, what do you think? Do you agree? Do you have more to add to that, or do you have different governance things you think are critical?
I mean, you realize that Kevin is truly the data scientist from both of us. So
Yeah,
that's,
that's true.
That's what he is seeing, and I can only agree to that. I mean, he's fully right. But let me also put another perspective on governance, which is maybe more the operation side of it, life cycle of it, because that is usually what is heavily underestimated in the beginning, where such projects start as a little POC, as a little lab environment, somehow turn it into production. But if you really then start to develop, and multiple people for multiple projects do create multiple versions, and not only on the model itself, but on the whole, let's say, pipeline to the model, like where's the data going or coming from, where's it going to, how do I bring the outcome of a trained model back into a process, how do I leverage and consume that? If you really think that through, then governance and operations means for me also you must be able to administer that and to operate that and to make sure that runs consistently in production, is repeatable and reliable. And then it's a complete different topic, because then in my example I made before with this 15 different environments and tools and technologies, if one of those technologies breaks, you will have the issue end to end, right? And therefore I can also on the governance and on the operations side of the house not emphasize enough how important this end to end thinking is, to really start thinking this whole scenario and whole use case through from the beginning, meaning where's the data sitting, where's it coming from, how does it look like, to what do I want to do with it and how do I then consume it. Because if you not tackle that, you can have the nicest model and the best insight and best findings, but you will not be able to operate and to bring it into production, which is, of course, maybe initially boring, but in the end, it's what makes such a project a success or not.
Mm-hmm. Good. Kevin, do you have anything to add?
I mean, I'd say that Mark's absolutely correct. And really, the concept that we think about all the time is this idea of an AI assembly line, right? So if you look at sort of the history of the Industrial Revolution, we can produce goods with hyper generalized people, right? And they can just do everything from start to finish. But where we saw, a massive step change in productivity was by creating the standardization of parts, the standardization of processes, and specialization along this sort of factory assembly line, right? So think of the Ford Model T. You had repeatable processes, repeatable standardized parts, and everyone just did their job and passed it along the line. And then the line moved and brought the jobs to the people who needed them. That's a physical construct. If you think about what an ERP system really is, you can think of that as the almost the factory assembly line for information, right? Routing the necessary information from one knowledge worker to the next, and that brought a step change in productivity as well. And I think the next piece beyond that is how do we take artificial intelligence and create the similar type of assembly line? So if we think about starting with data connectivity, how do I connect to manage data in a highly distributed environment? How do I make it possible to find that data and make it available? All of that is the realm of data ops, data architects, enterprise architects, data engineers. Then how do I pass that off to being able to extract some kind of insight from that? And this could be the realm of BI analysts, or in the case of machine learning, it could be the realm of data scientists who build that model. How do I then pass that off so that I can scale that that operation and automate it in the way that Mark is talking about? So there is no break that causes it to fail. In the BI world, that could be utilizing tools like SAP Analytics Cloud. In the realm of machine learning, that's really part of where data intelligence, both the data connectivity and the development and deployment of those models. And this is often the realm of IT operations. And then the last piece of this is how do I take the result of this and scale it out into the hands of the correct business users? So I may want to just make it available as a visualization in a report. I may want to integrate it directly into my business application so that a knowledge worker just sees the result of a model as they're trying to make a decision. I could want to improve or personalize interactions with my customers using something like a chatbot. So we have something called conversational AI that allows you to do that, but I can enrich that experience by feeding it with the results of all these machine learning models I've created. Or I may want to automate different business processes and completely remove a human from that particular equation. But what business process I use in what scenario is often informed by the output of these machine learning models. So we sort of see it as this large process chain. And if you're able to do that, your ability to scale and actually deliver business value and insights and take action against all of this data is a stepwise transformation that really would increase your productivity significantly. So it's really a shift in how we think about data science as something that's off on its own to how do we bring this into part of an end-to-end business process. And that's really what we kept in our minds as we were building this solution. And I think Mark really did a good job of talking about that. It may be one of the most boring things to think about, right? How do I make it repeatable? How do I make it operational? How do I make it scalable? But that's really where you go from delivering something really cool, but it's one of a kind, to delivering something high impact at massive, massive scale. And that's really the end goal here.
That's excellent. Thank you, Kevin. We just have a couple minutes left. I just want to end with one more question just to throw out there. So, I mean, SAP, we release lots of solutions, right? That's what we are. We're a software company. Is this just another, monolithical big solution where everything is like a big ERP, but like a platform version of that? And do I have to have ABAP to use it? Mark?
Yeah, maybe that's I don't know. That's what people think, but no. It's exactly the opposite. So, I mean, ABAP is always a benefit, right? It's for many years in the industry, but no, you do not need to know it. The solution itself, it's like I said, it's based on container technology. It's open, so you can bring your own model, you can bring your own library, you can use Java, you can use Golang, you can use whatever you want. Whatever can be squeezed in a container can run on our platform. And that's also, of course, it's for SAP also new, not kidding there. It's also for SAP a mind shift to say, hey, there is an open platform, bring whatever you want. We execute it and we make a life cycle around it. Believe me, what I learned the last year is crazy. A lot of words, a lot of technologies I haven't heard before. But that's exactly the strength of it. So everything can be squeezed in. We can manage it. We can execute it. ABAP does not hurt, but it's absolutely not needed. But of course, there is also for the ABAP gurus out there, there's of course also a way how you can delegate ABAP function modules and what have you to an ABAP-based system. But that's also it. So you should definitely explore and get convinced that it's not monolithical and it's not ABAP-based.
All right. Well, thank you guys for joining today. That's the end of our time. Kevin, appreciate you've done several of these podcasts. Thank you so much. Mark, thank you guys for joining, and we hope we'll see you on our next podcast. Thanks, everybody. Have a good rest of your day. Bye.
Thanks, Ginger.
All right.